This video is about finding the equation of cube root functions from the given table. Let's look at the general form of cube root function. Here A represent the vertical stretch, B represent the horizontal stretch, and HK represent the point of inflection. Point of inflection is that where the graph changes its concavity. We know that cube root graph is symmetrical about this point of inflection, and that's the property we are going to use to solve this problem here. There are two main steps to solve this problem. For the first step, first we write the differences in each consecutive x values. So let's write the differences. The difference between -26 and -7 is 19. The difference between -7 and 1 is 8. Difference between 1 and 2 is 1. Next we look at the differences which are same. These two differences are same, 19 and 19. Now the inflection point would be the midpoint of these two x values which have the same differences. We find the h value of the inflection point. For that we just find the midpoint of these two x values. -26 plus 28 divided by 2. That means the x value of inflection point is 1. K value is midpoint of the y values which have the same differences. K equals -3 plus 9 over which gives you 3. So we got the inflection point as 1, 3 is the point present in the table already. The first step is done. We have got the point of inflection HK as 1, 3. For step 2, we take fresh differences of x values from this inflection point. We take the outward jumps from this inflection point to each x value. From 1 to -7 there is a difference of 8. From 1 to 26 there is a difference of 27. Let us find their corresponding y differences as well. From 3 to -1 there is a difference of 4. From 3 to -3 there is a difference of, from 1 to 2 there is a difference of 1. From 1 to 9 it's 8. From 1 to 28, there is a difference of 27. From 3 to 5, there is a difference of 2. From 3 to 7, there is a difference of 4. From 3 to 9, there is a difference of 6. Then we write out these differences in a table. When the difference in x values is 1, the corresponding difference in y values is 2. So here we write 1 and 2. When the difference in x values is 8, then the corresponding difference in y value is 4. And when the difference in x value is 27, then the difference in y values is 6. And on the left side as well, when the difference in x values is 8, the difference in y value is 4. When the difference in x values is 27, the difference in y value is 6. So we write this in a table. Now we compare this table with the table of parent cube root function. X values are matching 1, 8, 27, but y values are not same. The y values are multiples of 2. This gives us the vertical stretch. That means there is a vertical stretch of 2. X values are same as the parent x values, so there is no horizontal stretch. Now we plug in values of A, B, H and K into this standard form. A is 2. There is no horizontal stretch. So we just write the values of inflection point. H is 1 and K is 3. So this is the cube root equation for the given table. Now let us work on a problem when there is a horizontal stretch. For step 1, we do the same. We find the differences in consecutive x values. The difference between -59 and -21 is 38. The difference between 21 and 7 is 14. This difference is 2. This difference is again 2. And this difference is 14. Now we find the differences in y values. Since the y values are decreasing, so there is a difference of -1. Now we look for the equal differences. We see that these differences in x values are same, so the inflection point would be the midpoint of these two x values, -21 and 11. Why we look at the same differences? because the cubical graph as well as the cube root graphs are symmetrical about the inflection point. That's why we look at the same differences. So here the x values which have the same differences are -21 and 11. So the inflection point would be the midpoint of these two values. -21 plus 11 divided by 2 gives you -5, and k value is the midpoint of corresponding y values. It's 9 plus 5 divided by 2, which is 7. So we get the inflection point as -5 and 7, which is present there in the table itself. We find the fresh differences of x and y values with respect to this inflection point. We take the outward jumps. The difference between -7 and -5 is 2. The difference between -21 and -5 is 16. This difference is 54. Next, we write these differences in a table. When the difference in x values is 2, the difference in y value is -1. When the difference in x value is 16, the difference in y value is -2. Same on the left side as well. When the x difference is 2, the y difference is -1. When the x difference is 16, the y difference is -2. When the x difference is 54, the y difference is -3. Now we compare these two tables. This is the table of a parent cube root graph. We observe that these x values are the multiples of 2. It's 2 times 8, 2 times 27. For the table we have 2, 16, 54, which are the multiples of 1, 8 and 27. That means there is a horizontal stretch. So there is a horizontal stretch of 2, and there is a reflection across x-axis because of these negative y values. Now we plug in the values of a, b, h and k into the basic cube root equation. We have a as -1 because there is a reflection across x-axis, and b is 2, h is -5, k is 7, which gets simplified to, and here we get the equation of cube root function for the given table.